All right, I've got my two websites up. Let's start here with the Intel processors, and it starts all the way up with the Intel Atom as the processor. They've got some of the codes or product numbers, code names, Diamondville, Pineview. They've got the speed. Now here's where it gets interesting. They give you the range of the speed, the clock rate of the processors. They tell you what socket it sits in. That's useful. Over here they tell you the cores. It could be a single or it could be a double core. They tell you the bus speeds that it'll support. And then remember, the other thing besides speed, core, was also the cache. And the level 2 cache on this processor could be as little as 512 up to 1 megabyte. Now I'm not going to read every one of these to you. You can see there's the Intel Celeron, the Pentium 3, and you probably have picked up on the fact that the top of the list is early in history. There's the Xeon. Boy, there's a boatload of those, and they can have some pretty significant ranges. Over here is the speed of that processor. Over here, your Xeon processor can have level 2 cache from 256K up to 12 megabytes, and level 3 from 4 to 16 megabytes. Pentium 4s, there's a bunch of them. There's a dual core. There's the Core 2, and then now we get down to my territory on my kit. There's the Core i3, the i5, and the i7. Now remember, mine's the i5. If we go across here, we're going to see that there are some product part numbers. Mine is the 3XX. It's actually an i5 3450, to be honest with you. The speed, I believe it's running in the neighborhood of right at about 3 gigahertz in speed. It's using the LG 1155. And then over here, mine is a quad core, as I mentioned earlier. And here's the level 2 cache. You can see the level 2 cache right there at 256. And the level 3 cache is in the range between 4 megabytes and 8 megabytes. And when we grab that processor and go to put it on the motherboard, I'll give you a little bit more details about it because I need to find the range in there. I think I said 4 megabytes on my PowerPoint. I'm not positive it's 4, but I'm going to actually look when I install it and tell you which one it is. 256 meg, listen to me, 256K on your level 2, and somewhere between 4 and meg on level 3, range of speed, and the processor. So obviously you need one of these websites, and you need to know specifically which model yours is, like my i5 3450, in order to be able to determine exactly what it is. This is the Intel website. Let's take a look real quick at the AMD equivalent. They got a lot of the same information. It's kind of organized a little bit differently. Over here's the architecture, the family, the code name, and here's your speeds. Boy, there's a slow one, a 386 running at 25 megahertz. Well, again, this is the top of the list. The socket. Over here is your level 1, 2, and 3 caches. Oh, there they are, cores. I'm sorry, my brain just froze up for a minute and my mouse went flying right past cores. Speed, cores, cache. Let's work our way on down. Now, as you're going down, one of the things you'll see on this list with the AMD is right there it says 64 plus 64. When you get to the bottom of the whole shooting match, they recreate the column headings again. So the level 1 cache is actually a 64 plus a 64. It's a pair of level 1 caches, each at 64. If we come down here and let's take a look, here's an Opteron. I think I mentioned that a couple of times, maybe driving you nuts. Opteron has a pair of 64 level 1s, 256 or 512 on the level 2s, and looks like 2 megabytes on the level 3 cache. Opteron is a quad 4. The speed could be between 1700 and 2500 megahertz, or 1.7 to 2.5 gigahertz speed. Let's go back to Intel for just a moment. I want to see if I can find out one other thing. Now, the Intel, oddly enough, does not have a separate column for level 1 cache. Isn't that interesting? There's the 3, there's the 2, and then there's the bus speed. But they don't have a separate column for the level 1 cache. A little bit later, I will tell you what the level 1 cache is on the processor that I have. Okay, there are tools out there like these sites at Wikipedia for your Intel or your AMD processors with a lot of those characteristics related to speed, cores, how many, and what is the level 1, 2, 3, and cache quantities and amount of memory in each of those level caches. That concludes this little demonstration on speed, core, and cache for our processors. All right, we just took a quick demo look at those two websites for speeds, cores, and cache size and type on our processors. A lot to memorize. Don't worry about it. Use the tools, but be aware that speed and the number of cores and the cache size and types that you have are ways of distinguishing between processors and their capabilities, and of course the speed and performance of your system. Now then, let's continue talking about CPU characteristics, and this time we're going to talk about something called hyperthreading. You may have actually heard of that before. Hyperthreading is a form of Intel's SMT, simultaneous multi-threading. In other words, more than one program can simultaneously have access to the core. I got a picture here that's going to be kind of helpful. Notice the picture at the top shows red, green, yellow, and blue rectangles in a large white rectangle. That's basically representing system memory. And it's representing 4 separate programs running in that system memory. I run that many programs in system memory on a regular basis. But here's what's happening. Coming down through that front side bus into this processor, it looks like both the red and the yellow programs are sending instructions or data. Now what we have is one physical core. And for each of the physical cores that are in this processor, there happens to be 2 threads of execution. Hyperthreading is that. It is simultaneous multiple threads coming to a single execution core. So what's going to happen is the operating system thinks that you've got 2 processors because it sees 2 logical cores or 2 virtual cores. That's the 2 different colors. So hyperthreading is from Intel. It's a way of making it look like multiple processors when actually what you have is sharing of a single execution core in that one processor. Another characteristic of your processors is virtualization. I've used this on a regular basis to teach some classes. Running virtual PCs. I'll have a virtual PC maybe running of XP, Windows 7, or Server 2008. Well, virtualization support in your processor permits you to create those virtual PCs. Intel has their process called VTX. They released this in 2005 with their Pentium 4 Model 662 and 672. They were the first to support. Many of the core processors now also support this concept of virtualization. Why is it useful? Because that processor that's on that motherboard has to be able to virtualize itself to all of those virtual machines you're running. I've run as many as 5 virtual machines on one computer that had 16 gigabytes of memory. 5 separate operating systems installed into 5 virtual machines and 1 physical processor. That's because the CPU supports virtualization so that each one of those virtual machines has virtual connectivity to that single processor. Again, starting with the Pentium 4 and of course up through the Core series, the Core iX series. Anytime you see me put that in there, Core, and then the lowercase I, and then square brackets with an X, that's the Core i3, i5, and i7s. AMD also has their own technology called AMD/V. They came out with that in 2006 with their Athlon. It's also available with Turion, Opteron, and their Phenom processors to support virtualization of that processor for your virtual PCs. Now then, let's talk about characteristics related to architecture. 32-bit versus 64-bit architecture. Both of these manufacturers have had 32-bit processors out for quite a long time. But recently they came out with their 64-bit processors. And what we want to do is make a distinguishing point when the first of the 64-bit processors came out with each of the manufacturers. Because at that point you're running a different platform. That AMD 64-bit and that Intel 64-bit processors fit onto some unique motherboards. You run a totally different operating system. You can't install a 32-bit Windows operating system on a 64-bit platform. You need to install that 64-bit operating system. AMD came out with their 64-bit processors in 2003 with the Opteron. Opteron was their first 64-bit processor. They also nowadays have, of course, the AMD Athlon 64, Sempron, and Turion 64. Intel came out with their Pentium D processor in 2005 as their first 64-bit processor. They also have the Xeon, the Core 2, the Dual Core, the Celeron, and of course the Core i3, i5, and i7 processors as 64-bit processors. Another characteristic to distinguish. Now, why do you care? Well, if you have a 32-bit processor architecture on a 32-bit motherboard, you're going to run a 32-bit operating system. And Windows 32-bit operating systems typically cannot access more than about 3.3 gigabytes of memory. The 64-bit laptop that I have and the 64-bit system that I have in my cubicle is able to address 8 to 16 gigabytes of memory because it's running the 64-bit architecture. 64-bit processor on a 64-bit motherboard, 64-bit OS of Windows 7 Professional, or the 64-bit of Server 2008 R2. Gives me a lot of value not only in the virtualization I just mentioned a moment ago, but with that new 64-bit architecture, you can go up to a whole lot more efficient system with a whole lot more memory running in a 64-bit platform. All right, another characteristic of our processors is the integrated graphics processing unit. Chuck, that's not news. We saw that in the chipset section. Yes, you did. In that chipset section, I talked about when it came out for both AMD and Intel. I also showed you my chipset, or my processor, excuse me, which is the Z77 processor chipset combination, and that graphics processing unit is integrated. So one of our processor characteristics, AMD combined the CPU and that graphics processing unit features on what they call the APU. That was the accelerated processing units. That was in 2011 with their Fusion strategy. AMD plans on, in 2013, to release something called Heterogeneous System Architecture, HSA. That's probably not going to be on the test at all. But what they're doing is they are rebranding their integrated graphics processing unit with that HSA architecture, and they're actually going to make it open architecture to the world at large. Intel, on the other hand, is not playing the same game. They're not opening up anything. With the Intel, they started combining that graphics processing unit with the CPU in their Core series. That was at the end of 2011. That's the Core i3, the Core i5 that I have, and the Core i7 series. It's when the integrated graphics processing unit happened with the Intel processors.